So let's say we have, just the example we'll do for a negative change in entropy. So let's say we have, I think I drew this on the board the other day, didn't I? When I like drew it wrong. So these were, what are these? What am I drawing right now? Lipids. Lipid bilayer assembly. Okay. And then I inverted my my bilayer. So the polar groups are going to be on the outside. The head groups, here are all my tails that are hydrophobic interacting with each other. There. So this system here obviously has low entropy. Okay? So the change in entropy, right, final minus initial, is going to be negative. Okay? But what we haven't considered, we're only considering our system as the lipid molecules themselves. Okay? So we haven't considered our environment / surroundings, which is full of what? What is the surrounding of cells and lipid bilayers? What are we mostly made of? Water. Okay. We haven't considered H2O yet. Okay. And this is forthcoming. But again, just so you know, delta S universe equal to delta S system plus delta S surroundings. Okay. This could be negative, or this could be negative, so long as this is still increasing overall. Okay. So the lipids can have a negative change in entropy, but that means the water and everything around it must have had an increase in entropy to accommodate it. So let's do our die example. Okay, rolling a die. So let's say I have, we'll do a non-energetic example, and then I'm going to go into the slides, and then I will give you an actual problem off of last year's homework and the previous semester's exam. We'll solve that one in teams and then take a break. And we can skip solving it, but I think that's what you guys want to do, right? Practice is better. Okay. So I have a dice here, and I have n number of them. Some number doesn't really matter. Okay? They are unbiased. Okay. They're six-sided. And the probability of rolling each number is equally likely. Okay. Given that information, calculate entropy, okay, as, leave it in this form, S over N KB, okay, equal to the negative summation of the probabilities. So first of all, what is T? I already alluded to this. T is equal to 6. What's P sub 1? And P sub 2? They're all equal to 1/6, right? We said they're all equal. What are the units of this? That whole term. Unitless. Entropy is joules per Kelvin. Boltzmann's constant is joules per Kelvin. Number of things doesn't have a unit. Joules per Kelvin, nothing. Again, I will probably rarely ask you to do it in this form and leave it as NKB, but this is how the book has a lot of practice, okay? And I don't want you to avoid doing the practice, okay? In fact, if you can understand it a bunch of different ways, it's probably better for you. Okay, so this would be equal to negative the sum. All I did is take my probabilistic definition. These two terms were over here, right? I've just moved them. So this would be 1/6, the natural log of 1/6, okay? Plus 1/6 times the natural log of 1/6. So this was for Category 1, rolling a 1, category 2, rolling a 2, category 3, okay, so on and so forth. So I'm going to sum this up over all 6 of my categories, so this would be -6 times 1 over 6, oops, the natural log of the 6. This is equal to -6 times -2.986. If anyone wants to check me on the calculator, that'd be fine. 1.8, okay? Obviously that one was pretty simple because there weren't any differences, yep. Where?
You have -6 times -2.
Yeah, -6 times -2 is not gonna make 1.8.
Yeah.
So
0.2.
here we go, 0.2. -0.2. I love that. See? Not to make anybody too sad right now, but there are definitely some answers on the quizzes that were not even conceivable numbers. Like your lungs can't be 3,000 liters big. That's way too big. My whole body, all my blood is like 6.5 liters, so there's really no chance that what's going on in here is 3,000. You'll get partial credit, don't worry. Okay.